Hey, my name is Ryan, and my main inspiration for this project was from the game Eco, and more specifically, from this cover art and from this song Heal from the original soundtrack. I've really liked this art and song for a long time, and I wanted to attempt to create something that made me feel a similar way. The first thing I did was compose a short song, and this song is composed of 5 tracks, one with these sort of arpeggiated chords, a bass line, a sort of secondary melody, some noise, and a vibraphone that's in harmony with the chords and melody. The main chords were synthesized in a wavetable synthesizer known as Serum and are mainly composed of this oscillator A and this sub oscillator here. Oscillator A is configured to have a unison of 3, which I put a very mild detune on because I wanted it to sound fairly harmonious. The wavetable position is modulated by this LFO1 here. The pan is modulated by note position, so if I play a lower note, it'll sound more from the left, and a higher note, it'll sound more to the right. Note velocity will modulate how loud the note sounds. And here we have a 78 milliseconds on the attack of the note, and envelope 2 is modulating the cutoff of this low pass filter here. For effects, we have some delay to give you that kind of echoing, some reverb to kind of fill in the space, and some EQ. The rest of the tracks, with the exception of the vibraphone, were synthesized similarly. Here's the bass, with some added distortion to give it a sort of warmer kind of tone. And here's the melody, or rather the secondary melody here. And that kind of gamey sound is being controlled by the wavetable position being modulated by this LFO here. And you get that sort of jumping sound because this is not a continuous wavetable. The noise is just some noise that I wanted to sound like a subtle wind. And you can see that LFO is controlling the panning of the noise. The vibraphone is coming from Studio One, the DAW I use. And the only effect put on that is a beat delay. This song was composed in G flat major with a time signature of 8/4, and here's what the sheet music looks like. Next, I needed a way to parse this audio data, and after doing some Googling, I found this MIDI parser written in C# by this user, David. So shout out David. And this allows me to export the data from Studio One as a MIDI file, and then get information on note events such as when a note was pressed and where it was pressed and how hard it was pressed. Here I am actually reading in the data into a list of MIDI notes, a class I created to make the managing of this data easier throughout the project. And you'll notice when we're reading in the first track, I add a 7 to 8 millisecond delay. And if you'll recall, that is because the chords and melody had a 7 to 8 millisecond delay on the attack. And after doing some testing in Engine, I found that the music didn't look like it was syncing up if I didn't introduce a delay, so that the actual effect is applied when the note is loudest. Once I was sure that I could parse audio data in Unity, it was time to build the actual visual scene. The first thing I did was start building a windmill model in Blender, but while I was working on it, I thought, wait a second, isn't there a entire scene with a windmill in the actual game eco? And indeed there is. The first thing I did was check the models resource, which I would highly recommend to any 3D artist. It's a website that contains a compendium of rips from all sorts of consoles and games and whatnot. But unfortunately, not for the game eco. However, I was able to find this GitHub repository that does exactly what I need. It rips 3D models from the game eco and converts them into OBJs and MTLs. So shout out user half-Asian. I was able to use the tool to extract my desired models here, and then I went ahead and cleaned them up and positioned them into an appealing scene in Blender. After I got this scene I was looking for, I imported it into Unity and set up some clouds, a sun. I remade the water here in Engine and went ahead and extracted all the materials. This is so that I could set the emission maps on each material to be the same as the surface albedo map. Setting this means I can get the detail of a texture even when the albedo map is unset and I'm only controlling emission on a material. Next, I needed some way to map note pitch to individual meshes so that I could apply an effect on a mesh based on note pitch. To solve this, I iterate through each mesh in the scene and then iterate through each material in each mesh, where in Unity each material is assigned to a unique submesh. And after I iterate through each submesh, I gather the bounding box center of a given submesh and convert the local space into world space. With that data, I can then compare this world space position to the lowest pitch and highest pitch in the track and literally interpolate that into a meaningful value. The top of the world and bottom of the world I defined with simple transforms in the scene. I stored this data in an object I call a glow object that allows me to call some functions I defined, make glow and vibrate, the visual effects you see in the scene. Make glow controls emission, and every time update is called, it will reduce that emission over time. Similarly, vibrate will make a mesh oscillate on the XZ plane using the sine function. Here's when these functions actually get called. You can see in the update function, every time a new note is played, I go ahead and check if what I call the pitch delta, which is the MIDI note's pitch subtracted from the linearly interpolated note space based on a bounding box's world space center, Y value. If that pitch delta is within our pitch delta tolerance, go ahead and call the make glow and vibrate functions on this glow object. To further elucidate, the pitch delta tolerance asks how far away from a bounding box center can we be before we are allowed to trigger this effect. I went ahead and made this a public property on the script so that it could be manipulated easier while designing this scene. And here's what it looks like with the default value that I've landed on. And here it is with a very high tolerance. Next, we have the particle effects that are cued with the secondary melody, and this is a simple burst system in VFX Graph, with the most notable features being gravity on the z-axis, the negative z-axis, to simulate wind in the scene, some turbulence, and the size over lifetime is controlled by a very sharp curve to give it that sort of glittering effect that will sync up with how the secondary melody sounds. Also, I am sorry for my cat. He is just very vocal, and I promise he is okay. The particle effects are then spawned in different positions in world space depending on the point of time in the song. Finally, to further expand on the other details of the scene, the clouds are volumetric and are configured in Unity here with wind. Same with the water. And the bird, windmill blades, and sun all have their transforms controlled by code. I had a pretty fun time with this project, and if I had more time, I would like to add things like blowing grass in the scene, maybe some more work on global illumination, and perhaps some rigging for the boy and the bird to make them look more realistic. I've published this project on my GitHub, and anyone is free to do whatever they want with it, with the only stipulation being if you do something cool with it, you gotta let me know. Thanks for checking out my project, and feel free to reach out if you have any questions.